Good evening, everyone.
Good evening, ma'am.
Okay, good evening.
Good evening,
So,
ma'am.
okay, so today we'll start with the section from where we left yesterday. Yesterday we were talking about the evaluation of analytical data, and yesterday we had discussed the concepts of mean, median, mode that you might be remembering, and we had also talked about deviation, the apparent error, that is what we call is as the average deviation, the probable deviation. We have also talked about the range of data. We talked about the standard deviation, and standard deviation which is represented by the symbol sigma, and it is given by the formula. Here it is represented in equation 3.6. We'll also talked about the sample standard deviation, which is identified by the small s. It is represented in this and has been represented in equation 3.7. Now, here in example 3.1, the one example, it has been shown how we can calculate the standard deviation of a given set of data. Here the solution has been done, and using both these equations 3.7 and 3.6, the calculation has been done. Then coming to standard deviation of the mean. So here the standard deviation of the mean, that is usually denoted as d mean, and it is given by d upon root over of n, where n is the number of observations and it is given as d by root over of n. So the mean of this deviation, that is called as the standard deviation of the mean, that is s mean, is given as s upon root over of n. Here it is shown in equation 3.10. We also talked about variance. So for variance, it is the for population for a variance is given by this formula here in equation 3.12. So using this equation, we can find out the variation. Now we have also learned about RSD, that is the relative standard deviation. Here it is given as S by X bar. Then we also have the percentage of RSD, in which is known as the coefficient of variation CV, and it is here it is shown in equation 3.16. So one example has also been shown to you, so you can do the example. Here it is in student activity question 2, and then you can find out how to calculate the CV, that is the coefficient of variation. Now we'll talk about the precision of the computed results. So this means that when we obtain a result, how we will know about the propagation of error or the standard deviation of the results that we have obtained. So let us say we have an final result W. So, and it is dependent on various types of functions, that is either A, B, and C. So here this W is a function of various individual variables. So now to find out the precision of our result, two levels of arithmetic operations can be done. So one is by either addition and subtraction, and other is through multiplication and division. So let us say that we'll consider the case of addition and subtraction. So let us say W is given as A plus B minus C. So therefore the variance of W will be given as the sum of the squares. Here as you can see, SW square is equal to SA square plus SB square plus SC square. So always remember, when we have a variation for addition and subtraction, it gives us the sum of the difference of the sum of the squares of the individual variables. So here in example 3.2, this has been shown how we can calculate of the standard deviation using the arithmetic operation, that is the sum addition and summation. But in the second case, when the W is dependent on the factors of multiplication and division, in that case the standard deviation is taken as the square root of the sum of the squares of the individual standard deviations. So here it is shown in equation 3.20. So here the relative standard deviation will be given as SA upon A square plus SB upon B square plus SC upon C whole square and total root over of that. So now, and from this equation, we can find out the RST to be SW by W to be this, and the standard deviation will be fine from this. So this is an example has been shown like this. So this is quite easy. So we can just need to remember the formula and put the exact values and find out the standard deviation. Then coming to this Gaussian distribution of data. So Gaussian distribution, this talks about the probability of the distribution of the data that we have obtained from our experiment. So there are laws of probabilities in an empirical ways, and that has been summarized in three ways. Like there might be some errors which occur with high frequency, there will be large errors which occur with low frequency, and there will be positive and negative errors that will occur with equal frequency. So these are the possibilities of errors that you can encounter during the calculation, during your analysis. So now when these three rules, we see when they are graphically plotted, so that plot is what we call it as a normal error curve, and from this curve we can find out the probability of our obtained results. So now here, if you look into this, actually this normal error curve is what we call it as a Gaussian distribution curve. Here in figure 3.1, it shows the frequency distribution curve, whereas in the x-axis we see the deviation, and in the y-axis we see the relative frequency. So here in figure 3.2, it shows the normal error curves. If you look into figure 3.2a, we see the deviation from mean is plotted in the x-axis, whereas when we see the normal error curve in figure 3.2b, the y-axis, it indicates the deviation in terms of mu. So this way we can say the frequency distribution curve can be rationalized in two ways, either in terms of sigma and in terms of mu. Now, the mathematical form of probability distribution is given from equation 3.21, and following this equation we come to the plot which is shown in figure 3.3. So this is a normal error curve. In x-axis we have the deviation of our observations, and here we have the relative frequency in the y-axis. So this is what this plot, it shows the average value where maximum population, the probable value of the population, it occurs. So this is what we call as a Gaussian distribution curve. So now in table 3.1, various values of error and their probability has been listed, and here you can see it has been written as, so for example, if we consider the first value here for 0.674 sigma, the plus minus y is given as probability is 0.5, and the probability smaller value is 0.5. So this means that 50% are in that their magnitude is in the order of, the error is less, and the remaining 50% is in their order is high. So this indicates the plus minus 5 y value here, the probability value, it indicates how much error lies within the plus minus scale. So here one example is given. Then now we will talk about confidence interval. This confidence interval is a crucial factor, and we need to know what does this confidence interval it means. So when we have a particular data, so the range of a particular value around the mean of the data is called as the confidence, or we call it as the confidence interval. The boundaries, that is the range of this data, they are called as the confidence limits, and the likelihood that the true value it falls within this range is called as the probability or confidence level. Okay, so and mostly it is expressed in terms of percentage. So whenever we say that the confidence level is above 98%, that means the probability of that value occurring is 98 percentage. So here when we talk of confidence level, we indicate in terms of percentage. Now confidence level, to calculate confidence level, we need two cases. So for first we need to find out the confidence interval, and it can be done in two ways. Now when the sigma is known and when sigma is not known. So whenever sigma is known, we have this, we finally the when we want to calculate the confidence interval when sigma is known, then we have a variety of equations, and using these equations we can find out what is the confidence percentage of the data. Here, like in example 3.4, it has been shown that the measurements of glucose levels in a patient, it gave us the following results. Now here the 95% confidence interval is given when sigma is equal to 0.019. So first, to begin with, we will calculate the x bar. Now here the number of observations is 7 and x bar has been found to be 1.101 grams per liter. So here in this question it has been given that the confidence interval for 95% confidence, the limits are plus minus 1.96 sigma by root over of 7. So once we get this, and then we can find out the value, what is the confidence limit. So here in this case, the value of sigma is known, and putting the appropriate values, we can find out the 95% confidence interval. Now, in another case, for calculation of confidence interval when sigma is not known, so this is for this process there is a statistical factor that is called as t, or sometimes it is called as t test or student t test, and it is given by this formula. Plus minus t is given by this equation 3.19. Like for illustrations, here the table have been given for various values of t and new degrees of freedom for different confidence levels. So now, for using here from this equation, from this table, we can find out the confidence interval. Now coming to criteria for rejection of data. So all the data that we have collected in an experiment is not useful for us. So some data, they need to be rejected. So the criteria for rejection, it might be due to some systematic error or any other factors. Now when we want to reject a data, so there are two types of rules. One is called as the 4D rule and the other is called as the Q test. So in the 4D rule, so this is actually, it indicates the 4 times of average deviation that we have obtained, and then we find out the distribution curve and the confidence level, and the following method is adopted. So for this test, what we do is the doubtful value is omitted, and we find out the first, we need to find out the arithmetic mean, then we find out the 4 times of the average deviation value, and then we obtain the difference between the unwanted value and the mean that we have calculated here. And if we find that the difference is greater than 4 times than the average deviation, then the data is rejected, otherwise it is retained. So this is how the 4D rule is used for data rejection or exception. Then the second test is the Q test, so which is used for very unwanted data. So this is also one of the methods, tests to imply which data should be rejected or which data should be kept. So for this process, the observations are arranged in one order, either ascending order or descending order. The lowest or highest or both may be the doubtful values. So then the range is calculated, which is calculated as the highest value minus the lowest value. Then the difference is calculated. So the rejection coefficient is Q is equal to Y by R. So then the table of Q, which is table 3.4, is consulted. When we compare this table 3.4 with our calculated value, and if we find that our calculated value is greater than the value that is shown in table 3.4, then the value is rejected. So then this is how we can find out which data to be kept or which data to be rejected. Here an example has been done to show you how to apply the Q test to check the rejection of the data in the following example. Then coming to tests of significance. Test of significance, it is important because in analytical chemistry we have a standard that is called as NIST, National Institute of Standards and Technology, and because we come across various types of errors during the analysis of a material, so the test of significance, it is much important. So we have 3 tests of significance. First is called as the T test, which is based on comparison of two mean data. This T test is also called as student T test. The second is the F test. It compares the two variances. And the chi-square test, it is measured in terms of frequencies. So first we'll start with the t-test or the student t-test. So here it is when an acceptable value is known, it is used to get the confidence limit and the population mean. So the quantity t here, we can define it as plus minus t is equal to x bar minus mu root over of n by s, where x bar, it indicates the average value, mu is the population, s is the standard deviation, and n is the number of observations in this series. So here in table 3.2 we have the values of t with probability levels 90, 95, and here it is shown. Now when we look into table 2, the we'll compare it and then we can find out the significance that our data has. Here it has been shown in this table. Now coming to the F test. This F test, it compares the variances between two observations. So here the F value is the ratio of two variances and is determined by the equation F is equal to B1 by B2, here given in equation 3.32. So if we have two variations and that is S1 square is greater than S2 square, so what happens here is the value of f will always be greater than infinity 1. So from thus the value we can calculate and then we compare with the calculated f value and we can find out the confidence level. Here it is shown in figure 3.5. Then coming to the chi-square test. So here the chi-square test, it compares your data in terms of your frequency. So a number of observations are taken. The chi-square quantity, it is defined as sigma fi minus fi whole square upon fi, where small fi, it indicates the observed frequency and capital Fi, it indicates the expected or the theoretical frequency. So here we have this comparison in from table 3.6. If here the chi-square calculated is greater than the chi-square that is present in table 3.6, there is a number bias and the confidence level here it is given. But if the chi-square calculated is greater than the chi-square present in table, here it should be lower than, then it is there is no bias and the fluctuation happens by chance. So here an example is given, you can go through it. Then coming to control charts. So control charts, use of control charts in an analytical chemistry is a must because it indicates whether a result it lies within certain confidence limits or not, and it shows the precision of the results. As you can see here in figure 3.4, a control chart is shown. So here is the date and here is the control and this shown. So from this figure we can know whether the data they are consistent, they are within the confidence level is or not, or whether it falls outside this limit. So control chart, the entries in control chart, they are important. And the here if we look into the plotted points that lies inside the particular level, so limits, so they give are the which lie within this line, they are up to a certain confidence. But the points which go beyond our five this line, so they are not needed and this data can be rejected. So that is called as control chart. So here in this unit, this is the summary of this unit. Some terminal important questions about calculation of errors and variances and other things have been discussed here with examples. So you can go through it and you can practice these numericals. Now coming to the next unit, this unit, in unit 4, we will be dealing with sampling. So sampling in analytical chemistry, sampling is the primary step. So once the sampling is correct, then the analysis of the material becomes easier. So however, sampling is also a crucial step and it requires brief preparation. So now before going to this, we should understand what is sampling. So sampling means to collection of a portion of a material. We have a material that we want to study. So collection of a portion of this material for analysis is called as sampling. Now the sampling process, prior to the sampling, there are certain the errors need to be corrected. So here the errors during the sampling, it may arise from environment, like mainly from air, water, or solids. So we have to monitor the environmental collection. And suppose we have a metal sample, we need to look into its interaction with the environment or its absorption with other surfaces. So these are some of the prerequisites for a sampling program. So now we will first there are various factors that are relevant to sampling. So first is the location, the time, the frequency, the air quality, and other factors. So whenever, even if we have a sample, there are the environment plays a crucial factor, the nature of the food, the nature of storage. So these are factors relating to different sampling. So now we will, in this chapter, we will talk about the sampling method for water, air, and solid waste. So to begin, first we will begin with water sampling. Water sampling, we know water analysis is very important because water is needed for life. Therefore, the quality of water, whether it is drinkable water or irrigation water, is important. And water sampling, water analysis is plays a huge role in the development of any industry or a nation. So when water sampling is done, the first point that is to be noted is the site selection. So whether the site selection, it means that whether we will choose water from a river, lake, or a pond, or from an urban area or an industrial area or a domesticated area or a residential area. So in this case, so we have to be precisely focused on the location. So first, when we have a site location for rivers, so when a river, it passes through a major city, that is also there is one method of sampling. So even we have a river where it is a fishing point, that also is also one point of water sample analysis. So there are from an industrial supply, so there are various site locations for river water samples. Similarly, when we want to collect lake water samples, we know river is a free flow, whereas lake is a enclosed body of fresh water. And particularly for lakes, four sites are available, like where principal feeder tributary meets the lake. Site 2 is a central place of the lake, the where we take out the water sample, a place where water is pumped for water supply for major city, and lake water is also available from a place where it is discharged from the lake. So now, so we can collect water from either rivers or lakes. Then coming to types of samples. Samples are divided, water samples particularly, they are divided into three types. So three categories. That is grab or catch samples. Source at that particular place. So this is called as a grab or catch sample, that is with exact location and time. Then composite sample, it means to the mixture of grab samples which has been collected at the same sampling point but at different times. So that is, the word composite always indicates a mixture. So here it indicates a mixture of grab samples. And then coming to integrated samples. So when we have a mixture of grab samples that has been collected from different points or the points which lie close to each other, they are called as integrated sample. So these are the three water samples that we usually come across. Now coming to sampling facilities. So here there are many sampling facilities where we can prepare our sample. So first is the bank side. So for the collection of the sample, we can depend on the river bank. But however, this is not a preferred method of sample because this is only used when no alternative is present. Then sampling technique facility also uses the boats. Now boats, they can take you to the reference point or they can take any point across the river or lake to collect your sample. Then the third are the bridges. Bridges, most water sampling has been done from bridges because the bridge point, it indicates from the bridge point we can collect our sample. We have a good access because the bridge is present and it indicates the true nature of the water sample. And then we have cableways. Cableways, they have been used when the river current is very high. However, cableways, they are not much used for water sampling. Also, water sampling has also been done by helicopters. So with the use of a helicopter, the water samples can be collected any point of the flowing river and with is easily, but this process is quite expensive in nature. That is why among all the sampling facilities, bridges found the greatest use for water sampling facility. Then coming to sampling frequency. So water sample that has been collected at a particular from different places, they it should remain, the composition should remain same. So what happens is, the larger the number of samples from which it is derived, the narrower will be the limit. So therefore what happens is, sample should be collected in large, so that there we can have a wide, the range of the data will be wide and we can know the exact composition of the water sample. Then coming to the sample containers and the equipment. So here, to measure the quality and the quantity of water by means of sensors which is lowered into position. However, most cases it is advisable. However, we cannot always do this. That is why containers, specific containers for water samplers have been deployed. A sampler of contain for water, it must be free from contamination. It should not change the water characteristics. It should have adequate capacity for storing the sample, and it should be resistant to the external factors such as pressure, temperature, so that the composition of the water does not change. So most of the cases, the water sampling bottle has been made up of polyurethanes. So they are soaked with 10% HCl for 24 hours, and then they are cleaned with distilled water properly. However, so this is one of the most commonly used polyurethane plastic bottles. So sampling equipments, they are many sampling equipments are present, but some of the equipments that are used for water samplers are, the first is the ball valve type sampler, which is used for collection of water at a very deeper depth. Then Dossard sampler, it is a bottle of convenient size and it has two holes. So here, this is a Dossard sampler. Then we have Fredinger sample, Kemmerer and Rutner type sample, Wales sampler, and Watt flask or JZ sampler. Okay, so these are the various equipments to collect water samples. Then coming to the sampling procedures. In sampling procedures, here we will see there are two ways. One is the conservative and another is the non-conservative method for our sampling process. Here in this non-conservative, and the third is non-conservative. First, the conservative, which does not change with time. The second is non-conservative, which changes with time. And the third is non-conservative, which changes rapidly with time and cannot be stabilized. So here, the sampling can be either, mostly they can be carried out either manually or automatically. So that depends on the ease of the process. So the simplest manual sampling is done by plastic bucket or a stainless steel jar that is fastened by a rope. So however, these are some that most common sampling method is just we dip the plastic bucket into the water sample. Then we will now discuss the various general procedure for sample collection of water. Now, when we want to obtain water samplers for analysis, the environment must be taken into consideration. The environment of the flow of the river or the lake must be looked into, and other factors should be taken. So whenever possible, like for sample collection, whenever it is possible, the container should be washed properly. Then the sample should be kept into the container. Then other points that require attention is the samples where water is well mixed. So here a large homogeneous matters such as leaves, rags, twigs should be avoided. So here then sample that facing upstream to avoid contamination by slowly drawing water. So complete information on the source, and this needs to be collected. Then after the samples have been collected, next comes the important task of preservation of the sample. So the physicochemical determinants that are present in water samples, which needs to be analyzed are the nutrient group, metal group, physical and mineral group, and organic group. So now general preservation of the nutrient group. So we know water is a collection of different types of groups. So first we will talk of how can we preserve the nutrient group. So for this purpose, we use dark colored HCl rinsed borosilicate glass bottles, and these glass bottles, they are used for the determination of TOC, that is total organic carbon, and COD, that is chemical oxygen demand. For the measurement of BOD, that is biochemical oxygen demand, with the samples, the water samples that have been collected, they need to be stored at 4 degrees centigrade. So once they are stored, this is, since this is a bio process, and it requires its analysis within 24 hours, because the problem arises with determination of BOD is the loss of dissolved oxygen. So once the water has been collected within 24 hours, it is advisable that it should be analyzed. Then dissolved determinants. So these are some of the methods how we can find out the dissolved determinants: by passing the sample through Whatman filter paper 42 and adding HNO3 to find the pH and analyze the filtrate within 6 months. Then metals group. How to know the metal group that is present, preserve the metal group that is present in water sample. So for this we add HNO3, and this will give us an analysis for chromium. If we add other, these are the other chemicals that have been listed, and we can find out whether Hg is present or not, or they can be preserved. So general preservation for physical and mineral groups. Suppose we have a polythene container and we can find out the pH of this, then we can preserve the physical and mineral group. Then container washing and preparation. The for the analysis, the specific we mostly use a borosilicate glass or a dark bottle. So here, so one in this part, we need chromic acid that should be rinsed with the bottle. If here the metals are to be analyzed, then one part of HNO3 followed by distilled water is added. If phosphorus is to be analyzed, then the container with a solution, one part of HCl need to be added so that they can be preserved. Now how can we preserve the different organic groups? So ideally speaking, there are various organic groups that are present, like polyaromatic hydrocarbons, here PAH, chlorophenoxes, and they should be stored at 4 degrees centigrade. So and maximum for a period of 4 days. So within the 4 days, they should be analyzed, else we will get erratic results. Now coming to specific preservation of individual parameters. So if we want to preserve the acidity of our water sample, then the container, the water should be collected in Pyrex bottles and stored at low temperature, and it should be, the determination should be performed within 24 hours or as soon as possible. So if we want to preserve the alkalinity, they should also be done in the same way. If we want to preserve the aluminium that is present in water, this process need to be followed. So these are some of the methods for preservation of arsenic, boron, calcium, cadmium, chlorine, chromium, these metals that can be preserved in our collected water sample. If we want to preserve the color of our water sample, it is advised that we should determine it as soon as possible, because storage might affect the original color of the water sample, because other biological process and as exposure to environmental conditions may deteriorate the quality of water. So to know the color of the water, the analysis should be performed immediately. So by using the other methods have also been developed for the preservation of metals like copper and ions like cyanide, fluoride, to indicate to the hardness of this water. So here the plastic, the container, it should be tightly capped. For the preservation of iodine, here it should be tightly capped and kept and stored at 4 degrees centigrade. So these are some of the processes that has been written how we can preserve the different types of components of the water. Silica, silver, selenium, strontium, sulfate, sulfide. Here to measure the specific conductance, actually we don't need to preserve the specific conductance. Here it should be measured as soon as possible. So also even the turbidity, it may be changed after storage. So if the storage it is measured immediately, we get the exact value. Now when we have water samples, they are also associated with various biological species. So just to study the biological analysis of water, we need sampling bottles that has glass toppered with them, and they should be covered with a black paper or a brown paper. Now, dechlorination of samples. So sodium thiosulfate should be added to clean dry sampling bottles in sterilized water. First, the foremost is that we should sterilize the bottles either by dry heating at 180 degrees centigrade for 1 hour or steam sterilization. Then the sample, it should be taken with utmost care to ensure that no contamination occurs, because once contamination occurs with the water sample, we will get different results. Now, when the sample is directly connected to a source, like collected like such as from water or lake or pond, then the area of it should be collected where the water is flowing, so that we will have a good idea. If we collect water from a stagnant source, then we get erratic results. So after this, special apparatus which permits mechanical removal of the stopper below the surface is required to collect the samples from the depths of the reservoir. So then size of the sample should mostly be 250 ml. So for biological analysis, a minimum of water sample is required, but in no case it 100 ml should be sufficient, but it is advisable 250 ml is the limit. Now, when water samples, it is always required that they should be directly examined once they have been collected. However, due to some constraints in the laboratory, it is not possible. Therefore, it is advisable that the analysis is done within 24 hours of collection of the samples. Also, there is possibility that we need to transit the water sample from one place to another place, and it is also required that during this transit the water sample should be carried in an ice box. So these are some of the processes for preservation and collection of water samples. Then coming to air sampling. The substances which alter the nature of the air, they are called as we know, they are called as pollutants. And pollutants might be CO2, SO2, CH4, or CFCs, that is chlorofluorocarbons. So, or we have pollutants arising due to anthropogenic activities, that is due to man-made activities such as industries, waste disposal, mobile or stationary combustion phases, agricultural practices. There are so many processes, human processes, that contribute to air pollution. Also, we have airborne particulate matter that gets suspended or dispersed in the air, and we call them as suspended particulate matter, that is SPM. Usually, these SPM are particles that are less than 20 microns. So, however, these particles, they have been narrowed down to determine the particulate matter size, and with their size has been reduced to 10 micron. So these particles are now called as respirable suspended particulate matter, that is RSPM or PM10, that is particulate matter 10 micron. So these are particularly harmful to us because they get stuck into the lungs and they cause further damage to the human body. So primary gaseous pollutants are those which are directly emitted from combustion surfaces, and they are like carbon monoxide, sulfur dioxide, and nitrogen oxides. So for this process, these are all gaseous samples, and thus the sampling for these pollutants, they follow a different route. Now, the selection for sampling locations. So, in order to study the air pollution at a particular place, we need to, whether it is a urban area or a rural area or an industrial area, we need to see that it is highly, the density of that place is high, so that when we make a comparison, we can talk about the topography, the density, and the different sources of pollution of that particular place. So the specific criteria for selection of a location is that the first is, it must be the situation, the location must be situated in such a way that the collected samples, they represent air that is breathed by the exposed pollution group. So therefore, this may be, it is indicated that we will collect the air from such places which have been maximum breathed by the by the living population. So therefore, it is advisable to locate the sampler at least 5 to 10 meters above the ground level, depending upon the building structures in the city. This proposition is quite sound in locating the samples. However, we need to this arrangement of collection of samples is sometimes difficult when we have a mountain area or a valley like area. Then suspended particulate matters. We know the particulate matters which are dispersed in the air, they have adverse effects on the human body. So the type of particulate matter and the sources of emission, here they have been listed in this table. Particulate matters, they include carbon or soot arising from automobiles, power generation space, refuse incineration, and other sources. We have metallic oxides and salts, then oil rotatory droplets, acid droplets, silicates, and other salts. And these are the sources from which such particulate matters they arise. They are actually a group of substance of the size and particularly 10 microns, and in a recent development 5 micron particulate matter have also been found. So the coming to procedures for operating the suspended particulate sampler. Now there are 9 procedures for operating suspended particulate sampler. So first is the filter preparation. The process for filter preparation requires the following steps. Here the first, we expose a glass fiber filter and we expose it to the light source, and then we discard the filter if it is visible. So when we find then the filter, it is the paper is accurately weighed and then it is unfolded, and finally with the, if there is a dry dusty atmosphere, the process is repeated for a 24 hours, and then we measure the weigh of the filter paper. This is called as the filter preparation. Then is sample collection. By mounting this filter paper on the sampler, dust sampler, it is first clear wiped with a duster cloth. Then these various processes are taken care of. Then comes the sampler operation. When the sampler, the shelter hood is closed for about 5 minutes, and then during the run process, the we need the manometer readings are made, and then for 1 minute, then the data is recorded, the flow rate is maintained. There are certain corrective measures that need to be done, and finally the closing of the sampler. This is the 8 steps, and then at the analysis at the laboratory. So here, after analysis, we can find out the filter paper is preserved, and then again it is kept into the sampler for further analysis. Now the maintenance of the sampler is also done, because it has a, because normally the running time is 150 running hours, and here during certain, these are some of the precautions that need to be followed, like during the carbon brush changing operation a cleanup is required. Here the gasket needs to be changed, the manometer, they need to be cleaned regularly. The air pollutants, mostly in the form of the gases or vapors or particulate matters, they can exist in various types of forms. So based on this, the sampling methods, they have been classified in terms of two ways: sampling of atmosphere without concentration of gases and vapors by collecting a known volume of air, and sampling of atmosphere with concentration of gases and vapors by removing the contaminants from a measured volume of air. So first we will study sampling of atmosphere without concentration. So for this, air samples collected without concentrations, they are called as grab samples. So here the evacuated samples, almost all type of evacuated containers, they can be used for the sample collection. Mostly plastic bags, they have been used for collection and storing of shipping gases. Then liquid or gas displacement methods, to fill a container with an air sample, a glass jar or aspirator is used. We have also used syringes for collection of air and air samples for this purpose. So here we have 2 to 3 types of methods by which for which we can collect air. Then sampling of air with concentration, here they have been labeled under 4 heads, that is adsorption in liquids, adsorption on solids, freeze out of the pollutant, and miscellaneous technique. So here, absorption in liquids, when we have a gaseous pollutant, absorption is done in a liquid solution. So for wide environmental sampling, so once the gas is absorbed by the liquid, and then we can find out, we can know the absorption, we can know the quantity of the gas sample has been collected. Now, this absorption occurs in two ways. One is physical absorption and another is chemical absorption. So, physical absorption, or we call it as the dissolution absorption, it involves the physical solution of the pollutant. So, these processes, they are usually reversible in nature, that we know. An ideal solvent, what happens here, it captures most of the gases, but however low efficiency is obtained for physical absorption. Unless and until the gaseous pollutant is very much soluble in the liquid, physical absorption is not a preferred method. In the chemical absorption method, the liquid, it reacts with the pollutant to form a product, that we know here a chemical reaction occurs. The primary factors that affect the choice of an absorbent are the solubility of the pollutant. So care must be taken to avoid an absorbent which will interfere with the analysis. So once the non-volatile product has been formed, it absorbs the gases with it and the gas samples has been collected. Now come, there is a term that we call it as the collection efficiency. So this indicates the extent to which a gas is absorbed in liquid. It is governed in general by the volume of the sample, and that is decided by the following factors. So what are these factors? The collection efficiency is dependent on the degree of contact between the gas and the liquid, the duration of contact between the gas and the liquid, the transfer coefficient or rates of diffusion between gas liquid phases, the degree of solubility of gas and liquid, the rate of chemical equation, the reaction, the concentration of the reactant, and the temperature. So, with the exception of temperature, all other factors are directly related to collection efficiency. The efficiency of the absorber can be calculated from also theoretical considerations. However, in practice, a collection efficiency of 90% or greater has been considered acceptable. And then coming to the absorber characterization. So the characterization is done on the following consideration. One of the major determining factors in collection efficiency of absorber is the rate of flow. So once we know the rate of flow, so if the rate of flow, then we can say how much the gaseous pollutant has been absorbed into the absorbent. Then coming to the size of the bubble. The collection efficiency of this process depends upon the probability of successful collisions of the reagent molecules to form with the bubbles, and we can find out the collection efficiency. Then the length of the absorbent column, it also depend efficiency also depends upon the length of the absorbent column, and that is, and also its height. The chemical characteristics. For greatest collection efficiency, we have to choose an absorbent which has a very large capacity for absorbing pollutant without building up any additional vapor pressure. So this is mostly done by choosing a chemical reagent which reacts with the pollutant in an irreversible fashion. So also we need to take into consideration the physical characteristics such as the pressure, temperature, the pollutant solubility in the absorbing medium, which also are directly related to the collection efficiency. So in most cases, there is a net, if we increase the temperature, it enhances the absorption reaction, but it decreases the collection efficiency here. Then coming adsorption on solids. Adsorption is a phenomena we know where the molecules are attracted on the surface. So with reference to air samples, what happens here is the gas is bound to the adsorbent by molecular forces, and if condensation does not occur, the gas remains unchanged. So two types of adsorption has been recognized. One is the physical adsorption, one is the chemisorption, or we call it as the chemical adsorption. So here physical adsorption is a general occurring process. Here, if the temperature is low, any gas, it tries to get adsorbed onto the surface. So the quantity of various gases that adsorbed under the same conditions is roughly a function of the condensation of the gases. So what happens here is it is directly the dependent on the type, on the affinity of the gaseous molecules with the adsorption surface. So also the boiling point or critical temperature of the gas is high, then we can see a higher amount of gas has been adsorbed on the surface. Then chemical adsorption, in contrast to physical adsorption, here in chemical adsorption it is mostly characterized by high heat of adsorption, and it leads to a stronger binding of the gas molecules to the surface of the adsorbent. So here the heat of adsorptions, they are of the same order or magnitude as the chemical reactions. Generally we see the physical adsorption phenomena is used in air pollution control work, and this this adsorption is also used to in the collection of radioactive gases. Then characteristics of adsorbents. The best adsorbents are those which have a very porous nature or cracks or channels, but they can resist breakage and structural deterioration. So, such materials are prime examples of good adsorbents. The absorptive capacity for various gases and vapors, it closely parallels their critical temperature, but the quantity of gas that can be absorbed, it also depends on various types of factors such as the concentration of the gas in the vicinity of the adsorbent, the total surface area of the adsorbent, the temperature of the system, the presence of other molecules that interfere for the sites with of the adsorbent, then the presence of other the characteristics of adsorbent in terms of its weight, electrical polarity, reactivity, size and shape of the molecules, and the shape and size of the pores of the adsorbent. So these are the factors that influence the physical and physical adsorption of the gases onto the adsorbent surface. Now, ideally speaking, the physical adsorption of gas is highly favorable because we have a high concentration of the gas pollutant that absorbs on the surface of the material of our material. So the most widely and commonly used only important non-polar solid is carbon, that is mostly in the form of activated charcoal. So we know activated charcoal or charcoal, if we burn wood, it is very effective in absorbing non-polar organic substances from atmosphere in preference to atmospheric moisture. Now polar adsorbents are the oxides of silicon or of metals. The metallic oxides that are like alumina, that is from bauxite. Activated carbon is considered the adsorption of choice for sampling odorless gases because of its high adsorptive capacity and non-selective characteristics, because we know that this activated carbon is a highly porous material. So, and it does not have any adsorptive preferences. Plus, the presence of pores, it makes activated charcoal a good choice for a adsorbent material. Now, desorption from this activated carbon, once the pollutant gas molecules have been adsorbed onto the surface of the activated charcoal, the desorption may be accomplished by using superheated steam or by heating the activated carbon in vacuum and distilling the dissolved material in a cooled trap. To dissolve the substances from the silica gel or activated, the nitrogen may be passed through the adsorbent at ordinary temperatures or 250 degrees centigrade. Now also, apart from this, solvent extraction method can also be used for the desorption from of the gaseous pollutants from the activated carbon surface. So now we see how activated carbons is used to capture gaseous pollutants from the gaseous pollutants for analysis. Now, coming to condensation or freeze out of the pollutant. So this means that the samples, they are collected by drawing the air sample through a single cooled trap. That is, mostly they are immersed in refrigerant bath, or the temperatures of the collecting traps are very low. So that is why they are called as condensation or freeze out of the pollutant. So the collection traps, they are of double wall construction with the airflow passing through the space between the walls. The sampling assembly is usually, it is a glass construction, mostly dewar flasks or other insulating vessels which contain the refrigerants. Here the freeze out methods, they have the advantage of concentrating contaminated gas or vapors and preserving them in their natural state without any chemical reaction. One of the greatest drawback of chemical adsorption is that it has to undergo a chemical reaction. But here in the condensation process, the gaseous pollutant is directly trapped into the collection, into the collector vessel, and in its neat state, in its natural state, without the occurrence of any chemical reaction. This method is particularly useful when the concentration of the gas is extremely low, and when highly concentrated samples are required for subsequent analysis. So here even low concentration of gaseous pollutants can be collected by this method. Then there are other miscellaneous techniques for evaluation for collection of atmospheric gases pollutants, such as impregnated substrate technique, where lead candle method is used for measuring sulfation rates. Then is the direct reading instrument, and third is the static devices. Like for example, the effect of air pollution on vegetation, they suggest the use of plants as static device for the assay of air pollution. So what happens here is, when we want to see the influence of air pollution on a particular crop, then the use of plants, they serve as a static device. The plants, they act as static device. A static method for the determination of hydrogen sulfide gas by lead acetate impregnated tiles and filter papers. The degree of the darkening of the exposed surface is then compared with the calibration standards, and then we compare it with our calibration of the calibrated results to find out the level of H2S that is present in the air. So this is how plants have been used as static devices. Then the next unit, we will be talking of sampling of solid wastes. So before starting this, we will take a break of 5 minutes, then again resume with the sampling of solid wastes. So now we'll start with sampling of solid wastes. So here solid waste, it means the waste that from domestic, commercial, official and institutional sources that is generated from these sources. So the general requisite for sampling of solid waste, it means that we have to be particularly careful about the source. So once the source is secured, then we can talk about the true nature of the composition of the solid waste. Suppose we have, like here it is written that we have a compost. So for a particularly for a compost sample, the grab samples like in the range of 1 to 2 kg, they may be taken from many parts of the locality possible, and it has to be mixed with equal parts. Then this 1 to 2 kg actual sample it should be happen, and then this way in this way they are kept in plastic baskets, and then they makes the way for the crude sample. This is how a compost sample is collected. Then sewage sludge. So before the for collection of sewage sample, the it is well it should be well homogenized first. Now here this homogenization should be done with a high speed agitator. So here the after it has been mixed properly, it is subjected to dehydration to remove the water from the sewage sample, and then we can they can be stored and they serve as the finally they serve as the crude sample. Then after this is how we collect sewage sludge. Then the residue that is obtained after incineration. So incineration, the crude sample is directly taken from the after the incineration from the incineration area. The fly ash can also be taken from these corresponding areas. Then the sample size of it depends on the kind of information sought. Like for longer examination periods where several single samples are taken, the quantity may be fixed at 100 kg per sampling. So it actually depends on the type of the test that needs to be performed. So for the preparation sample, what happens is once we get the crude sample, they need to be ground and homogenized after drying. So the moisture content of the crude sample is determined. Then it is essential that the moisture content of the sample is also measured as soon as it is collected. So this is how the crude sample is first dried, it weight is obtained, the moisture content is obtained. Then comes the next step of segregation and grinding. So these waste material, they might contain glass and other metals and plastics. So they may be separated, these glass and ceramics, they may be separated by sieving process. Then the plastics and non-ferrous metals, they can be the ferrous metals, they can be removed by magnet. The remaining material, they may be pulverized using a crushing mill, a hammer mill, knife mill, until they become a homogeneous powder, and then they can be shifted through 0.5 screen. So after this screening process, this material is now ready for analysis. So thou said this material may be further segregated into organic and inorganic portion. So the organic portion, it consists of mainly paper, rubber, plastic, wood, textiles, cork. A part of this material may be further pulverized and mixed with the sample. So this is of importance. If it is, we need to know the carbon content of the sample. Then the mass of the remaining material shall be determined and expressed as a percentage. The inorganic material, it contains almost exclusively all of the metals. Now they are cleaned with air pressure and the mass they are determined. So the inorganic screening residue, it is considered inert while calculating the calorific value. Then coming to sampling of food materials. So this is how we do the sampling of the waste, solid waste. Then it also includes the sampling of food materials. Now food materials also we need to analyze their quality for human consumption. So here first there are two main procedures for sampling of food materials. One is known as random sampling and another is known as representative sampling. So here random sampling, it includes that some portions of the bulk are taken in such a way that every part of the product has an equal chance of appearing in the sample. This is a random sampling. Then we have representative sampling. The sample is taken in such a way that the each portion taken it represents corresponding to the part of the bulk. So here the operation it has been shown in here in this figure, but figure 4.1, what we call it as the quartering. So in this figure, in homogeneity of T is an example of a erratic sampling. So replicate analysis is done, and here how it has been rejected, how we can see which sample to be kept and which sample to be rejected. So here in summary of this part we can tell that we talked about the various methods of sampling of air, water and gaseous samples, and also we talked about the sampling of food materials. These are some of the questions and that you can go through it. So with this we complete this unit of sampling. Now we'll talk about a new unit, that is about the safety in a chemical laboratory. Now, since we are working in a chemical laboratory, it is of primary importance that we talk about, that we ensure that we are working in a safe environment. So there are various safety procedures that we need to follow in a laboratory. So now we will start with how, what is safety aspects in a chemical laboratory. Now we know there are many potential hazardous and dangerous chemicals that are present in a chemistry lab. So first, when we talk about the safety aspects, the some of the general requirements while setting up a lab, some of the general requirements that need to be followed are: there should be adequate provision for lighting and ventilation. So the it should be a very well ventilated and well lighted area. There should be effective measures to prevent the inhalation of fumes that might while arise during the experimental work. The dangerous part of a machinery, they must be properly kept so as to avoid any accidents. The laboratory must have sufficient first aid boxes with the essential constituents. The fire prevention measures must be present there. There should be sufficient means of escape for all persons in the course of a fire. Here in figure 5.1 we can see a modern chemical laboratory. Now when we, these are the some of the requirements when we are for the design of a chemical laboratory. Then coming to the safety aspects, when a chemical laboratory is functioning, for the efficient running of a chemical laboratory, the condition of the building, furniture, they must be at least checked. So all at the time of purchase of gas cylinders, the instructions, the manufacturing dates and the expiry dates must be clearly looked into. The lab staff, they must be well equipped and they must have protective clothing against the chemicals, hazardous chemicals. In addition, the laboratory staff must have appropriate training in terms of handling of chemicals, using the gas cylinders, in terms of storage of chemicals, waste disposal. Also the critical is the laboratory staff must be well equipped in administrating first aid in case of any accident. The lab must also have a list of important phone numbers and addresses in case of any emergency. So the laboratory must have the contact numbers of nearby doctors, hospitals, police, emergency services, gas water supplies, firefighting supplies, and these are the some of the critical factors, criteria that should be maintained for the efficient running of a chemical laboratory. Now, coming to the code of practice in a laboratory, this means the do's and don'ts of a chemical laboratory. So, coming to the do's, the first requirement is always to wear a lab coat. It is essential, followed by wearing of gloves and goggles. Then, secondly, we should always wear shoes to protect our feet, closed cover shoes, not the open toe shoes, so that we are protected, the whole foot is protected. Then we should not leave our hair open, the hair must be tied. The hands, we should be wearing gloves. Hands should always keep away from, we should always keep our hands away from the friend's face while we are using chemicals. We should actually know the position of the main electricity switch and the gas supplies while working in the laboratory. We should be well aware of the use of fire extinguisher and other safety equipment that are present in a laboratory. We should check for instrumental damage during the working of a laboratory. We should also inform the faculty and lab staff if there is any breakage or defect during the running of the laboratory. Then if we have any spill of chemicals or acid or alkali, we should, it should always be cleaned. The apparatus which are no longer liquid, they should be kept separate. A fume hood must be present for for absorption of the toxic gases that come out during the course of a reaction. Then other operations that are hazardous, that we should always be ready to get help or assistance. And then the labels containing the hazardous chemicals, they should be always, the containers should be labeled. Then the all we should always use safety bulbs while pipetting. So the hands must be washed before leaving the laboratory. The laboratory should always be cleaned. The doorways and emergency exits should always be well ventilated and they are not obstructed. So here these are some of the do's that we need to follow in a chemical laboratory. Now, the don'ts of a chemical laboratory requires that we should never eat, drink, or smoke inside a laboratory. We should never sniff new materials or ever taste any chemicals. We should not never smell the contents of any container without knowing what type of chemical is present. We should never work alone in a laboratory. We should never perform any unwanted experiment so to satisfy our curiosity. We should not we should always leave the we should always we should always close the bunsen burners after the reaction has been done. We should never work with any unknown chemicals from the laboratory. Even whenever we come across any smoke arising in the laboratory, we should always inform the lab staff. The lighted cigarette may help in the formation of poisonous substances in the presence of some chemicals. That is why smoking is strictly prohibited in the laboratory. We should never use any any unwanted chemicals or unattended chemicals in laboratories. We should not run about or play about in the laboratories. We should not touch with the dilute or concentrated acids. These are some of the don'ts of the laboratories. So while working in a laboratory, these are some of the do's and don'ts that we need to follow. Now we are then coming to the potential protective devices. So here some of the protective devices that we need to follow. The first is the lab coat. It is mandatory to use lab coat because and it should be in full sleeves and half full length sleeves. So what happens here is it protects the knees and the hands, and that is the first line of protection between us and the chemicals. So an advantages of using cotton coats is that they do not spark static electricity. So here most cases it is advisable that cotton made lab coats should be used rather than using a nylon made lab coat. So nylon, it melts when it senses heat and it also dissolves in some organic solvent. So that is why cotton lab coats are more preferred. Then safety goggles. While working with chemical reactions, eyes must be protected, and that is why goggles are a must. Then gloves. Gloves are recommended while we are working with corrosive liquids. This prevents our hand from further infection and damage. So the the three main safety protections that we need, that is highly recommended while working in a laboratory, is a lab coat, the safety goggles, and the gloves. Now, chemical hazards in the laboratory. We know that our laboratories, they are equipped with all sorts of chemicals. Now here let us learn how a chemical exposure can occur to us. So these chemicals, they can harm us in a number of ways. So they can be exposed to us by dermal exposure, which means by exposure to the skin, inhalation, ingestion, fire, and explosion. Exposure means that the toxicity, when the our skin is directly exposed to the hazardous chemicals. So once our skin is exposed to these chemicals, we might induce irritation, itching, and further cracking of our skins. Then is inhalation. It is most dangerous route of chemical exposure into the body. Therefore, if we come across any unwanted chemical, we should always avoid inhaling it. Some of the most poisonous gases are chlorine, hydrogen sulfide, ammonia, hydrogen cyanide. So inhalation of these gases, they can be disastrous. Then the third is the ingestion. So ingestion means referring to the exposure of chemicals through the mouth, that is through the oral cavity. So sometimes the dust particles or the smoke or the reaction fumes occurring in the laboratory, they enter through the oral cavity and finally they go into the gastrointestinal tract. So that is why we should never pipette directly by mouth. We should never eat in the lab. We should always wash it by hand. So these are the some of the methods of exposure of chemicals to our body. Then effect of chemicals on this body. Some of the class here, we know that these chemicals have very deleterious effects on human body. So some of the classes of chemicals and their effects on human body have been discussed below. Like acids, we know they are highly harmful to to our body. They cause severe burns and damage. Alcohols, they irritate mucous membranes. Methanol causes blindness. Aldehydes, ketones, they causes irritation and problems in absorption and ingestion. Alkalis like NaOH, KOH, they cause bronchial spasms. Carbon monoxide, it makes difficult the transport of hemoglobin in blood cells, which further cause leads to death. Sulfur, phosphorus, and nitrogen compounds, they invite respiratory diseases. Cyanides are, they are highly fatal in nature. Esters, they cause tissue poisoning. Ethers, they have a narcotic effect, and halogens are corrosive and irritating to tissues. So mercury, it is also quite toxic in nature, and they are followed by certain permanent defects in our body. Then coming to the acute and chronic effects. So the effects that are due to chemicals and immediate on the human body are called as acute effects, and they can be traced without difficulty. However, chronic effects are those which are hard to be find, and they are long term, and they will be detected at a later phase. So that is why self lab practice is always required to avoid the acute and chronic effects of chemicals on our body. Then is the fume cupboard. The cupboard, it actually, if the reaction, whenever a reaction is proceeding, a risk of inhalation or the risk of the fumes is there. So the cupboard, it absorbs the reaction fumes, and it ensures that the dangerous vapors are vented out to the atmosphere and not to the human body. Here in figure 5.2, a fume cupboard is shown. This is how a fume cupboard is worked. Now coming to classification of hazardous materials. Sorry. Now we know a hazardous materials, it causes potential damage to human bodies. So that is why the UN Committee of Experts on the Transport of Dangerous Goods have classified hazardous materials into different classes. So the first one is the class 1, that is explosives. These explosives, they are like some of the examples are gunpowder, nitrates, nitro compounds, detonators, etc. So they belong to class 1 explosives. Class 2 explosives are those which has a critical, that is gases. The gases, not all gases, but the gases which has a critical temperature below 50 degrees centigrade, it has a vapor pressure of more than 3 bars. So here, when gases, they have been additionally subdivided into 3 classes. Flammable gases are the one which contact fire on exposure immediately, they catch fire, such as acetylene and hydrogen. Non-inflammable gases, they are neither flammable nor poisonous, and poisonous gases like those who directly cause death or injury, such as fluorine, chlorine, or HCN. Then class 3 are the flammable liquids. So flammable liquids are those like petrol, alcohol. These liquids are flammable to definite degrees, and they have been classified into 3 categories. First are the extremely flammable liquids. These liquid chemicals, they have a boiling point lower than or equal to 35 degrees centigrade, and they are called such as diethyl ether and carbon disulfide. They are extremely flammable liquids. Then the second class is the highly flammable liquids, such as petrol or acetone, which have a boiling points greater than 35 degree, but the flash point is below 23 degree centigrade. And the third category includes the flammable liquids that do not belong to the above two, that is kerosene and diesel. Then the fourth class of hazardous chemicals are the flammable solids. So here the flammable solids, some examples are camphor, straw phosphorus, sodium sulfide, some alkali metals. They have also been subdivided. So they classified as flammable solids. That means which are easily ignited and combustible. For example, nitrocellulose, magnesium, etc. Then we have spontaneously combustible solids, that is, these solids that ignite spontaneously, like for example, white phosphorus and alkyl aluminiums. The class 5 of hazardous chemicals are oxidizing substances. The oxidizing substances, they have been divided into following three classes: oxidizing agents other than organic peroxides, such as calcium hypochlorite, ammonium nitrate. We have the second class, that is the organic peroxides, such as benzoyl peroxide, cumin hyperperoxide, etc. And the third is the dangerous when wet, the solid substances that becomes flammable when they are wet or react with water, such as sodium. So once normal sodium, when it comes in contact with water, it becomes highly flammable. The class 6 of hazardous chemicals are the poisonous and infectious substances. So this class has been divided into two subclasses, such as toxic substances. These are the substances which causes death when we inhale it. For example, potassium cyanide, mercury chloride. Biohazardous substances. Biohazardous means the substances which are of biological origin. So these have been divided into two subclasses. One is the infectious substance affecting humans and animals, and the waste or reusable material. These are derived from medical treatment of an animal or from biomedical research, which includes the production or testing of biological products. So these are also called as biohazards. Then the class 7 of hazardous chemicals include the radioactive substances. Here, the radioactive emission, we know they have been classified into three types, that is alpha, beta, and gamma. So, the symbol for radioactive, we know it has been shown, it is yellow on a yellow background. So, radioactive substances, the substance, the radioactive material which emit these radiation are radioactive substances. The class 8 is corrosive substances. These substances, they cause severe corrosion to the tissues, such as HCl, sulfuric acid, which comes in contact with our skin. And the class 9 is the miscellaneous dangerous substances. This class includes other substances which are not included in the above class. Now, when we know how to identify a hazard, they have the identification, they have a particular distinctive background color. So these colors, they indicate the type of explore the type of hazardous materials they are associated with. That is, if it is explosive, the color of the background is orange. If it is flammable, it is red. If it is water reactive, it is blue. And if it is corrosive, it is black and white. So this is how the here, even if you look into the side of these figures, you can see how the colors have been recommended. Then coming to carcinogens. Carcinogens, as the name implies, they are cancer-causing substances. The chemicals which causes cancer, such as aniline, benzyl chloride, pyridine, chromates of lead, zinc. So, in addition, these are the chemicals which causes cancer. So, they are called as carcinogens. Now coming to storage and handling of chemicals. Now we know there are a variety of chemicals that we come across in the laboratory. So the first task is the storage and handling of chemicals. So before we need to how we can store a chemicals, before that we need to understand the incompatibility of the chemicals. Incompatibility means that if a chemical is incompatible with other chemical, then they should not be stored together. So storage is of chemicals is divided into two types. One is random storage, one is alphabetical storage. So here in random storage, as the name suggests, there are no restrictions. We can keep the chemical in any place, in any like, in any wherever we like. However, this is not a preferred method. The second is the alphabetical storage. So this is how most of the chemical laboratories across the world, they store their chemicals in order of the alphabetics. Then categorical storage. Here in categorical storage, they have been divided in terms of categories, such as flammable chemicals, acids, bases, or toxic compounds. So this approach is useful, but mostly this is not followed. So thus, for recommendation of storage of chemicals, we can summarize that all chemicals must be properly labeled and stored in a ordered manner. Mostly alphabetical order is followed, and properly labeled chemicals must be used to store liquids that are highly, those that are highly, they are volatile or flammable in nature, they should be properly labeled and kept aside. Now here in this table, some of the common chemicals showing incompatibility with other chemicals have been listed. Like for example, acetic acid is incompatible with chromic acid, nitric acid, ethylene glycol, perchloric acid, peroxides and permanganates. That is why it is advisable that acetic acid should not be stored near these chemicals. So this is the list which shows where how which chemical compound is compatible with other compounds. Now coming to handling of chemicals. So while whenever we work in a laboratory, we must have a list. There is a protocol to follow, so we must know about the proper handling of chemicals. So first, to begin with, label. The label on the container or the chemical, it should indicate the name of the chemical. It should also indicate the nature of the chemical in terms whether it is explosive, it is oxidizing, it is flammable. It should also, the label should also indicate a risk phase, which shows the general nature of the risk, and a safety phase, which gives advice at the precautions to be taken. The label on the chemical, it should also indicate the name and address of the supplying company. Now this information is just sufficient for us to know the type of chemical that we are using. The common handling of chemicals, it involves like decanting dangerous liquid and transport bulk materials. So decanting dangerous liquids means if we are working with liquids, so we can expect whenever we are transferring chemicals, liquid chemicals from one bottle to another, so there are possibilities of drips or spillage. So in such situation, we need to take care, we need to ensure that there is proper safety around us, such as in terms of a sand bucket or a mop or water supply to stop this drips and spillage. There is also a possibility of splash. So in case of the question, we should, whenever we are transferring liquids, so we should also see there is, if there is a possibility of splash, and whether our laboratory is well equipped to prevent these splashes. Then coming to transport of bulk chemicals. When we have bulk chemicals, like suppose we are transferring say 2 liters or 5 liters, so then the following precautions must be observed. Like never we should carry the bottle from its neck, because it might easily slip from our hand. Also, these bottles should not be carried in bare arms. We should have a carrier basket to carry this bottle. The carboys of concentrated acids, liquids, it must be vented out. Whenever possible, the carboy should be left in store, and then the stock bottle should be kept in store, and from the stock bottle we should dispense the acid or base as per our requirement using a siphon. Then coming to safe handling of glassware. So glass apparatus, we know it forms the basis of a chemical laboratory. So glasswares, we have different types of glasswares such as test tube, conical flasks, round bottom flask, standard flask. So therefore, it is advisable the proper handling of this glassware. So some of the common steps to follow during for proper handling of glasswares is that we should keep the glassware away from the tabletop. Each piece of glassware should be clamped on the reaction flask. Now, whenever distillation is formed, then the glassware should be secured or clamped properly. Not all types of glassware they can sustain high temperature or pressure, so we should always look into the manufacturer instructions. We should use thick globes so as to prevent any cuts that might arise during the glassware's handling. So here some of the some of the precautions that we need to be taken has been written here. Then coming to equipment and electrical safety. So many times there is due to electrical mishap. So some of the possibilities of an accident in the chemical laboratory might arise, so such as improper wiring, improper choice of fuse, deterioration in the insulation system, accidental touches, breaking in earthing system, so improper functioning or operation of conventional tools. So some of the simple precautions that we can follow to avoid mishap from electrical appliances are that we can use heating mantles properly to prevent electrical shocks. We can always check the cord or plug to ensure that it is not damaged. The plug should always be disconnected from the socket. Water should be kept away from all electrical equipment. So the electrical wires, we should always ensure they are working properly, and they always running across the floor. They should not be running across the floor. They should always be over the top of the room. So because dangling electric wires, it causes major accidents in the lab. Then certain emergency procedures. So in case of any emergency or accident in a lab, so some of the procedures that we need to follow. However, first let us first learn about the possible accidents that might happen in a lab. So first is the chemical burns. Burns might This is a very common case that occur in a chemical lab. This might occur due to the accidental exposure to acid base or other chemical methods. So and they directly get into the skin or into our skin. Therefore the first aid is highly essential in this step. So first we need to wash the area with cold water to limit the tissue destruction. Then we should avoid using any neutralization solution to the affected area, which then rather after washing we should directly go and consult a doctor. So if in case a chemical falls into the eye, that is an ocular burn, we should not rub our eyes. It should be washed with water, and then all it should be highly in after washing they should be directed to the doctor. Then thermal burns, they are caused when a flame comes in contact or a hot object comes in contact with our skin. So first we should remove the victim from the source. Then we should not use ice. So directly it causes body heat loss. Once the burn has been cooled, then we can go for the sterile dressing. Then finally after that we can, for immediate action, we can refer to the doctor. Then cuts and wounds, they are very common arising from glasswares. So first of all, this might lead to bleeding. So in case of minor bleeding, the wound should be washed and then it should be tapped with a dry pad. To then for when we have a major wound, after washing it with water, applying a tight bandage, and then we should consult a physician or a doctor. Suppose while working in a lab we do come across the ingestion of chemicals. However, this is very far this is less common, but still the possibility sometimes occurs when we have a when we are pipetting in the mouth. So the ingestion of chemicals might occur. So if the material that we have pipetted, it is corrosive, then repeated mouthwash with water is best. However, then we should not try to give any chemical to neutralize the influence of the affected material. So then we should immediately rush to the medical for help. Now if we have inhaled any harmful gases or vapors, we should move the victim to fresh air. Then if the victim is unconscious, we should check for breathing, and then we should also apply artificial respiration and then call the medical. So suppose anyone splashes chemicals on the skin and the eye, so it is therefore we should first wash it with 10 to 15 minutes with cold water, and then we remove the contaminated ornaments in that area. So however, we in this process we should not put any neutralizing agent, and then we directly consult a doctor. Now doctor, for if we have fractures, so it is, although very uncommon, but any broken or cracked bone might, due to some accident, fractures might happen in a lab. So here in this case, we should directly cover, here in this case we should directly consult a doctor. And the recommendation, any movement in any part here, the when we talk of a splint is a thin rigid strip of metal that has been used to keep a broken bone in place. So the best general treatment is to cover the casualty with a blanket, the keep the casualty warm, then we can call for an ambulance. So in case of a fire, if our clothing catches fire, we should immediately drop to the floor and roll to smoother the flames. So if a compound that we are working with it catches fire, we should cover the flames, we should directly wash it, lots of water should be, and do not put water on any organic chemical fire because it spreads the fire. So we should wash our clothes but not put water on the organic chemical. So if the fire is large, we should evacuate the lab immediately. So and then we should call for a fire alarm. So these are some of the safety precautions that we need to take while working in a chemical laboratory. So here in this chapter we talked about the various types of hazardous chemicals that we are dealing with and the various methods by which we can work safely in a lab. So in this unit these are some of the questions that you can practice the questions, and some self-assessed answers have been given. So the websites and book has been given. So I guess with this we finished this unit 5 on safety practices in a chemical laboratory. We also talked about sampling. So this much for today. We will again meet at the same time tomorrow. Thank you for today.
Thank you, ma'am.
Thank you, ma'am.
हेलो हेलो गाइस, मैं शंकर पंडा बोल रहा हूँ। आप लोग तुम लोगों को सुनाई दे रहा है? हेलो हेलो।